Alright, so we had our extra practice for 6-7 on Friday, and you got hopefully those two taken care of now. Any questions on 1 through 3? Did 1 as a class. Okay. We did 4 as a class, right? Okay, so there's 5 and 6. Obviously, you could have moved your axes around, but okay. Number 7. A sub n is equal to 1/3 times a to the n minus 1, or excuse me, times a sub n minus 1. And number 8, a sub n is equal to a sub n minus 5, or n minus 1 plus 5. So a sub n is equal to a sub n minus 1 plus 5. Hey, we just tossed it in the inbox. Thanks. Okay, questions on those two? All right. Number 9. A sub n is equal to 1/5 a sub n minus 1. I think we did that one as class. Number 10, a sub n is equal to -3 times a sub n minus 1. And number 11, a sub n is equal to a sub n minus 1 plus 6. Number 12, a sub n is equal to a sub n minus 1, all minus 3 there. And number 13, a sub n is equal to 1/5 a times a sub n minus 1. Tell your neighbors how you did on 9 through 13. Hey, any questions on those? 14, a sub n is equal to 4 times 3 to the n minus 1 power. Number is equal to 11n minus 5. If you left it in this format right here, make sure you multiply it in. Okay, multiply that in 11 times -1, 11 times n. And then combine your -11 and 6 to get that -5. So if you didn't do that, make a note to yourself. Number 16, a sub n is equal to negative. And if you put the 1 there, that's okay. But it's -5, or negative times 5 to the n minus 1 power. Questions on 14 through 16? Number 17, a sub n is equal to a sub n minus 1 plus 6. Number 18, a sub n is equal to -3 times a sub n minus 1. Number 19, a sub n is equal to a sub n minus 1 minus 2. Questions on 17 through 19? Okay, those last ones I asked you to just find a pattern for. I want to actually describe how we're going to do these. This says write a recursive rule for the sequence, then write the next 2 terms. Okay, I want you to tell your neighbor what the pattern is for number 20. What's happening every time?
Adding.
Better yet, like when you're looking at this and you go, hey, I'm adding 2, adding 2, adding. Okay, so we don't have a straight up arithmetic sequence. We're not multiplying by anything. So anytime you see something like that and you're trying to write a recursive rule, then it's helpful to see if you can somehow look at the numbers and figure out how to get this number from that number. And usually it's helpful I find it helpful to start at the 3rd term. Okay? So if I'm looking at the 3rd term, not at my phone, but at the 3rd term. Okay, if I'm looking at the 3rd term, and I know it's the 3rd term, remember, because this is when we're dealing with sequences. We can kind of think of it as a table, right? 1st term, 2nd term, and so on. Okay? If I'm looking at the 3rd term, how could I get the 3rd term using the previous terms? Well, I'm going to leave that up for you guys to figure out there. Who has it? How do you get the 3rd from the previous 2? Mercedes, what do you think? So you're adding what? Very true. Okay, adding 2 to the 4 to get 6. How can I use these two terms to get that term? Oh, add them together. Is that what you meant? Okay, but you could add them together, yeah. All right, well, let me ask, if I want to get the fourth term, could I do the same thing? Yeah, I could add 6 and 4. What about if I want to get the fifth term? What am I adding? Good. If I want to get the sixth term? Okay, so this is a form of what's called the Fibonacci sequence. Okay, where you're actually taking the two previous terms to get and adding them up to get the third term. So the way we write that, if I want let's say the third term right now. Now I'm going to write it in a specific format and then go to general. If I want the third term, what two terms am I adding?
1 and 2.
The first and second. I'm adding the first term and I'm adding the second term. Now the problem with writing it like the way I'm writing it right now is that you have to keep writing that for the rest of your life. This is a very specific format. Because I would say, I go, okay, you got the third term, how do you get the fourth? And then you'd have to go, okay, well, to get the fourth term, I'm actually adding 2 and 3. And I go, okay, well, how do you get the fifth? You go, well, to get the fifth term, you'd have to add 3 and 4. Okay, that becomes very annoying and irritating and redundant. So what we would do is write it in a general format. Well, if I wanted the nth term, a sub n, I would need to add what? The previous two. So how do I get to the
a sub n minus 1 and a sub n minus 2?
Good. If I take away 2 from 5, I get, okay, so that's a sub n minus 2. That means 2 terms before it. And I would add it to 1 term before it. Okay, so you have to get in the habit of being able to write in this kind of language, right? Okay, this is saying if I want any specific term, for instance, I want the 7th term. Well, a sub 7 will be a sub n minus 2, or 7 minus 2, which is 5, plus 7 minus 1, which is 6. The 5th and the 6th give me, what is it? 42. Well done. Okay? And if I wanted a sub 8, I would have to add the 6 plus the 7 to get
78.
okay? Any questions there? All right, we'll try 21. Once again, if you're not just have a straight up recursive, or arithmetic or geometric, try to say, what can I do to these two to get to that? Or these two, or try to figure out a way to tie these all together. Okay? Talk with your neighbor out and see what you come up with. Okay, anyone figure out what you're doing? Jilly? Good. Okay. So if we're looking at it kind of in that format, 1 minus 3 gives you negative 2. 3 minus negative 2, which is like 3 plus 2, gives you 5. So if I want to find, if I just start with the third term again, and we kind of write it that way first, the third term is the first term minus the second term. And so now to write it in our general format so we get our answer, our nth term, well, 3 to get to 1 is subtract 2. So we take n and subtract 2. Minus, so this thing right, for those of you struggling seeing this thing became that. Okay? And then a sub 2, to get from 3 to 2, you subtract 1. So that's n minus 1. Okay? That is that. Okay, this is your solution. This is your general form. Pretty good. Yeah? Yep. You can test them out. What are going to be our next two terms? Negative 7 minus 12 is negative 19. And 12 minus negative 19 is?
No, that's positive.
Positive 31, yeah, because you're doing a minus and negative. Okay? Okay. Try number 22, last one. All right. Tell your neighbor what you got.
I still haven't done them ever. 1 plus 1 plus 0 plus 2 plus 4.
Okay, Bella, what are you
plus
doing?
24.
1 times 2 is 2. Okay. So the next term is equal to or minus 2. Either one, right? Yeah, you could write it like that, or since you're multiplying, you could write it the other way around. You could do n minus 1 times n minus 2. Okay? Either one of those would work. So once again, let me get your assignment going here. Those of you who are wondering about those next two terms.